Everywhere you look, companies and governments are announcing billions of dollars in new AI infrastructure. But we're counting what they plan to build before asking a more important question. Can they actually build it? Texas is becoming the perfect test case. Roughly 65% of its data center capacity, now under construction, is located in areas facing high or extremely high water stress. And that's where the AI boom starts looking very different on paper than it does in the physical world. Because chips and investment dollars are useless without the power, water, and infrastructure needed to keep them running. Texas offers cheap land, abundant energy, and an attractive environment for massive data centers. That's exactly why developers keep building there despite the growing water constraint. But the exposure is actually getting worse. About 57% of operating Texas data center capacity is in high or extremely high water stress areas, compared with roughly 65% of capacity under construction. So this isn't a future problem waiting for the AI boom. The AI boom is already being built directly into it. A typical 100-megawatt American data center consumes roughly 2 million liters of water per day, according to the International Energy Agency estimate cited by Bloomberg Intelligence. AI campuses are now being planned at several times that scale. Microsoft already has 338 megawatts of operating Texas capacity in high water stress areas. Crusoe has roughly 600 megawatts under construction in stressed areas, while Powerhouse Data Centers has roughly 2 gigawatts. This is where the AI boom collides with something markets can't solve with another GPU order. The physical infrastructure underneath these projects has limits, and water is only the beginning. Data centers need enormous amounts of electricity, while parts of the power system producing that electricity can also require water. Texas still relies heavily on natural gas generation, and thermal power plants can require significant water for cooling. During a severe drought, AI infrastructure can therefore face water pressure directly at the data center and indirectly through the power system supporting it. That turns water scarcity from an environmental issue into an economic allocation problem. Agriculture, industry, households, power generation, and data centers all depend on infrastructure built around the same limited resource. And the result isn't simply higher water prices. Scarcity can make the entire system more expensive to finance. Corpus Christi shows how quickly that feedback loop can develop. Recent rainfall improved its immediate water outlook, but the region still requires major investment in desalination, groundwater, and water reuse. The city's water system debt has already been downgraded. Bloomberg Intelligence estimates that the difference between AA and A borrowing costs could add roughly $105 million to $120 million over 30 years to planned water infrastructure spending. That's the part of this story investors shouldn't miss. The shortage makes infrastructure necessary, the infrastructure requires debt, and weaker credit can make that debt more expensive. So the cost of solving scarcity rises because scarcity exists in the first place. That additional cost eventually flows into water rates, taxes, corporate expenses, or the economics of future development. Now, apply that back to AI. A massive data center announcement means much less if supporting it requires billions more for power, transmission, cooling, and water infrastructure that wasn't included in the headline. That's why announced AI capacity and economically viable AI capacity are two different numbers, and markets spend far more time talking about the first one. Big tech is already adapting to this reality. Google's Meitner campus in Texas is designed around air cooling, while Crusoe is using closed-loop, non-evaporative cooling at its Abilene project. Vantage is also developing its Frontier campus around near-zero water usage. These aren't just environmental decisions, they're attempts to remove water as a constraint on future computing capacity. But there is no free lunch. Reducing dependence on evaporative water cooling can shift more of the cooling burden toward electricity, depending on the technology and operating conditions. That means solving one physical bottleneck can put more pressure on another. Use less water, and the power system may have to work harder. And that creates another unexpected winner from Texas's water problem. Wind and solar don't require the same cooling water infrastructure as conventional thermal generation. Texas has roughly 71 gigawatts of operating generation located in high water stress basins, with about 40% coming from coal or natural gas. In those regions, water-light electricity starts carrying an economic advantage that has little to do with the usual climate argument. This changes the AI investment chain again. The first phase was chips, then data centers, electricity, natural gas, nuclear power, transmission, and grid equipment. Now add desalination, water recycling, treatment equipment, pipelines, and advanced cooling systems. AI is creating infrastructure demand far outside the technology sector because computing capacity ultimately depends on physical capacity. Texas estimates roughly $174 billion of water supply investment could be required through 2080. More than $300 billion of economic output could be at risk if the state fails to make enough investment. But those giant numbers aren't the most important part of the story. The real lesson is that the AI race is becoming a competition over physical resources. Cheap electricity isn't really cheap if billions must be spent securing water. Cheap land isn't really cheap if the grid and pipelines around it need massive upgrades. And a $100 billion AI announcement isn't worth $100 billion simply because somebody announced it. The infrastructure underneath the project determines how much of that ambition can actually become operating computing capacity. That's why Texas matters. It's giving us an early look at the gap between the AI economy investors can model on a spreadsheet and the AI economy that can actually be built. The first AI race was about who could get the chips. The next one may be about who has the power, water, and infrastructure to keep those chips running. Because AI may live in the cloud, but the cloud still has to live somewhere, and the physical world is starting to send us the bill. If you enjoy looking beyond the headline to find the forces actually moving the global economy, like the video and subscribe to Global Notes by JP. I'll see you in the next one.